Hello everybody, my name is Henry Aguayo, and my scope of work presentation is going to be on continuous footings. So what are continuous footings? Continuous footings, or called strip footings, are used as foundations of load-bearing walls. The footing usually has twice the width as the load-bearing wall. Sometimes it is even wider. You can see a picture right here. Down here would be your continuous footing. Excavation. So in order for you to put your footings in a project, you first have to excavate, and these are types of equipment that are used in excavation in projects, such as excavators, backhoe loaders, bulldozers. Footings are the base of a foundation. Concrete footings are the basis of a project. Concrete is one of the most important scopes of work in a construction project. Many companies strive to be the greatest in this field of work. Some large general contractors actually self-perform concrete, like Hensel Phelps. That's one company that self-performs in concrete, and typically large GCs would hire subcontractors that are experienced in concrete. So here are a few tools that are used in concrete and continuous footings. So subcontractors would use shovels, wheelbarrows, tape measures to measure the lengths of our footings, hammers, rebar benders, trowel, an edger, and a groover. So when dealing with concrete, in estimating, it is taken off by cubic yards, or by cubic feet and then converted to cubic yards. When estimating footings, the volume is determined by taking the linear footage of each item times its cross-sectional area, and typical waste range of 5% for continuous footings. Here is a picture of drawings that show continuous footings. Here you have your column schedule and your footing schedule over here, and you have all your sizes, and right here's the drawing. So on Bluebeam you could measure the length of the continuous footing for CF1 that is listed here on the schedule. So the question I had to do was question 21 from the book, and says, using a waste factor of 7%, determine the number of cubic yards of concrete needed to pour the continuous footing shown in figure 11.36 and 11.37. Assume that the wall is centered over the footing. So the first step I did was I calculated the cross section of the footing, the area, so base times height of the footing, which I got from this picture right here, the base and the height. So it was the base was 2 feet 6 inches and the height was 1 foot. So multiply those and you get 2.5 feet squared. and then you calculate the perimeter of the building using the formula. So I use this formula right here, which is the perimeter of the building is equal to 2 times length 1 plus length 2, because you want to account for all the area around the building. So there's a, you can see right here, the 25 feet, and then on the bottom right here is the 36 feet. So you add those two and then multiply by 2 and you get your length. And then you calculate the volume of the concrete required to lay the continuous footing. So it's the volume, which is area times the length. The area that we got from the areas we got up from right here times the length, and we get a volume of 2.5. We get a volume right here of 305 feet cubed. So we want to convert that to cubic yards, so divided by 27, and then we are told to add a 7% waste factor, so we multiply that by 1.07 and we get 12.09 cubic yards. The second question: determine the amount of rebar needed for the continuous footings shown in figure 11.36 and 11.37. Allow for 2 inches of cover and extend the dowels 15 inches into the wall. Add a 10% for lap and waste continuous bars. Okay, so first step was calculating the perimeter. So the perimeter of those guys, again, 25. One side is 25 and the other side is 36, and then multiply by 2, which is 122. We got that answer from the last problem. And then calculate the length of the dowel. So the length of the dowel is equal to the length of the wall going in. Yeah, the length of the wall and the wall with the footing minus the cover. So the length of the wall right here was 15 feet, and then we add that to our width of the footing, which is 1 times 12 minus the cover 2, and we get 25 inches. And then the amount of rebar needed, so I wrote it down as a formula. Rebar is equal to N1L plus N2L divided by S times the length of the dowel. So it was, I got that 4 times 122, because the rebar that we're dealing with is number 4 rebar, and then add that to the 5 times 122 feet of perimeter divided by 12 times the 25 inches that we got from the length of the dowel, and the rebar is equal to 1,758.83 feet. So then I added the 10% waste factor by multiplying your answer by 1.10, and we get 1,934.2 feet of rebar. Okay, so the third question was determine the number of linear feet of forms needed for the continuous footings shown in figure 11.36 and 11.34. So it's the same figure that we used for our last problems. So I added up all the sides from all the sides for the perimeter, and the total was 122, which we determined in our previous problem as well, but I just showed you this way, adding all the sides together gets you that same 122 feet. And then we multiply by the 1 inch 1 foot 3 inches of the length of the dell here to find out how much linear feet of the forms we needed, and then multiply that by 2 because you want to account for one on each side, so it's 2, and the total linear feet is 366. So that was my presentation on continuous footings, and I hope you enjoyed.